Welcome to another DevOps.com webinar. Thank you for attending, and let me tell you a few things before we start. All the information and the presentation will be available after the webinar. It'll be available on DevOps.com. Also, if you have any questions, simply type them in the question box. Or if you have anything you want to say at all, type it into the question box and we'll respond. Today, we're talking about the evolving role of a build engineer in managing open source. We're lucky to have two distinguished guests in Pete and Sean from ActiveState. And what I'd like to do is introduce the gentleman from Canada and really turn it over to Pete to talk more about the topic. Pete, how are you today?
Pretty good. How are you?
Good. Take it from here, Pete.
All right. So thanks everyone for coming today. Sean and I are going to talk about build engineering and open source. So what we're going to talk about here is build engineering and its role in managing open source. And I'm going to go through some of the high-level topics about, where it sits in the software lifecycle and how it fits into your development process. And then Sean will take a slightly deeper dive and look at some of the specific examples and some of the particular issues and pitfalls that you might run into when you're involved in build engineering. So as introduced there, I'm Pete Garson, Senior Product Manager at ActiveState, and I'm working pretty closely with developers and to help make our products kind of best in class. And ActiveState's had a pretty long history with open source, going back 20 years, starting with Perl on Windows, and was also one of the founding members of the Python Software Foundation. And so has a very long history dealing with open source and open source languages. We have about 97% of the Fortune 1000 companies as clients of ours. And what we've got is a number of language distributions spanning Perl, Python, Tickle, Go, Ruby, but also an evolving platform that is looking to bring build engineering across your enterprise and make it more automated and streamlined and simple to use across your entire organization. Sorry. So when we're talking about open source in the enterprise here, what we're looking at is that open source software is really everywhere inside the enterprise. As much as 95% of IT organizations are leveraging some kind of open source, according to Gartner. And according to Black Duck, which surveys enterprise applications, almost 90% of applications are comprised just of open source software. So that's a significant portion of an application is using open source. And as coming from Black Duck as well, you also see that a lot of them have vulnerabilities because managing open source is actually quite complex in the sense that there's a large number of sources that the source code is coming from. So that's one of the things that you need to keep in mind here is that when you have your open source, you have more attack surface, but also more repositories to manage, and that in terms of the build engineering process, more robust tools and more robust processes around build engineering can help. So, I mean, that means other than having a single repository, so if you were all working with closed source code, you would have maybe one single source code repo. But right now, you're managing many different repos. So, what's your process to manage that? If you are managing all the different updates, all the different security, all the different licensing on all those very disparate sources, do you have a process or is it sort of ad hoc? And so that's where something that like build engineering comes into play. So you're looking at what is build engineering, and who are the people who do build engineering? So you're talking about developers that have ecosystem knowledge. So they know where to get source, where to get tools, and where to get the the things that they need to do a build. People with systems knowledge who understand uh, how the different platforms work. What are the difference between Linux and Windows and Mac OS? And then also people with process knowledge. Where does this fit in the entire software lifecycle? Where does it fit in relation to your CI pipeline? All that kind of thing. And then what are the things that they're doing? You're looking at people who are going to be locating canonical sources of libraries, languages, and tools. Where do I get the definitive version of package X? Where's the latest version of this tool? Then also compiling those sources into artifacts. And as you'll see, from Sean's presentation, sometimes compiling those sources into artifacts is not so straightforward and easy. So there's definitely some challenges there. And then we're also looking at packaging those artifacts for distribution. So once I've got I've compiled my library, how do I get it out to the developers on my team, as well as down the road in terms of how do I get it out the door to other, to customers. So where does build engineering sit in relation to software development lifecycle? We're looking at something that sits quite far to the left, right? It's right at the beginning. It's sort of taken for granted because you have to do some amount of build engineering in order to do any development whatsoever. So it sits right at the beginning of the life cycle, and it's something that you have to do both to get started and to do continuously in order to keep on working. So you need to constantly be making sure that your project compiles in order to keep working. And anytime you introduce a new dependency, you have to make sure that that works. So really tackling a lot of the same problems that you're tackling in DevOps, but for development. So one of the things is because you're doing this throughout your software development lifecycle and you're doing it continuously, there's a hidden cost because you're doing, whether or not you have a dedicated person doing build engineering at your organization, you're doing this already, whether you know it or not. And so who are the people who own these tasks within your organization? It's often distributed across many developers, incurring costs that aren't measured or accounted for on an ongoing basis. In a recent survey that ActiveState did, it showed that over 75% of developers surveyed said they spend at least part of their time managing dependencies and their development tools. And combine this number with over 61% of respondents stating that they start a new project at least once per quarter. And there are a lot of overhead and getting configured and getting things working. And that kind of cost that is being distributed across your team when they could be spending time on your sort of mission critical applications. So one of the ways that you can eliminate those hidden costs, and one of the ways that we're working at ActiveState with the platform to eliminate those costs, is to try to automate build engineering. So in order to try to reduce those costs and the workload on those developers is looking to automate the build engineering process. And some of the things that we're looking to automate are things like environment configuration. So getting your environment up and running, dependency management, managing all those various libraries and packages, and then build execution and storage in terms of not having to manually figure out how to get something to build, how to make that automatic. So what are some of the challenges that you run into when you're trying to automate these things and systematize, componentize these builds? Is trying to make it seamless, effortless, and reproducible across your organization, because the reproducibility in your development process is critical for testing, deployment and development, because without it, nobody's really speaking the same language. without reproducible builds, you don't really have a kind of predictable development process, and you're having to do a lot of sort of on the fly fixes and hacks to make things work. So if we put these into sort of different categories, we're sort of landing on a category of environment configuration, which we'll talk about here, dependency management, and build reproducibility. So with environment configuration being getting my project even set up to build whatsoever, dependency management kind of being the ongoing process of managing versions for my various libraries, and then build reproducibility in terms of having this systematized and automated in a way that I can translate and move it to any other person on my team or any other customer and have them be able to reproduce my build exactly. So we look at environment configuration maybe in a little bit more detail here. This is really the first link in the sort of dependency management chain. And it really encompasses everything that you need to start building. So that's obviously very, very important for reproducibility, because if we're not building from the same environment, then there's no way that we can really end up with the same build if we don't have the exact same environment. So there's a lot of different things that need to be considered and tracked when we're talking about environment configuration here. So we're talking about like tool chain setup, and meaning like my compiler versions, or what compiler am I using, what supporting libraries do I have here, what SDK version for a particular SDK that I'm building across, how am I representing that build environment? Is it just a setup process that I have to do on my local developer machine that's maybe mixed with a whole bunch of other things? Or is there some kind of container solution where I'm building a Docker image, or is it a dedicated machine somewhere in the building? So these are different sort of different options that you have here, but all around giving me a reproducible build environment. We're also looking at different OS versions, system libraries. There's a lot of different variables that go into just getting my environment set up to a point where I can even start building. And then obviously everybody's sort of heard of the popularly known dependency hell. And this is actually probably where a lot of time is lost when you're managing different packages. And so obviously you have to deal with version pinning. Is everyone on your team really just pulling the latest from GitHub? Sometimes that's the case, right? Where you are just, people are running off bleeding edge versions, which in development might be okay, but it also might not be, depending on how fast the project updates. Where are you getting your source from? Where are you getting your binaries? If you're using a system library that's pre-compiled, where are you getting your binaries from if you're not building from source? Where does the source live? Is it reliable? Can I reliably be able to go and get, a particular version of this project from a source repository? If I have a very large, long, complex dependency chain, then how am I managing things like CVEs or licenses within that complex dependency chain? Certain language ecosystems like JavaScript that will have, like Node.js will have very, very large dependency chains within projects. And so how are you monitoring all of those things for CVEs and licenses? Chances are a lot of your developers probably aren't. And so you don't really have visibility into what's going on in terms of vulnerabilities, but also licensing in your organization, whether you have GPL code that's embedded 10 layers deep in a dependency chain. And obviously you have things like conflicts between different versions of libraries that might have shared dependencies. and how do you deal with that? What's the process for dealing with that across your team? And then, as Sean will talk about a little bit later on, loosely coupled dependencies and licensing is an issue. So things that are optional, that are not potentially required at build time. And then how do you automate the monitoring and allow you to apply policies to these things as well? So if I have all of these various components and I have this huge library of code that I'm managing, is there a way that I can both automate the monitoring and apply policies that are specific to my organization against these? So these are all kinds of hard problems that we're sort of looking to solve here. So some of the wins, if we automate, obviously, is like we're going to gain a lot of developer time. We're going to gain developer sanity by not having to deal with a lot of this stuff manually, and we're going to reduce technical debt. So without a systematized automated solution, you probably have a collection of ad hoc solutions that are kind of cobbled together, maybe unique to each developer or package on your team. And instead of having a universal solution that automates everything from end to end. So some of the other benefits too of having an automated system is that you get a few features for free or things that weren't possible necessarily before. So we say things like free speculative builds. So if you are working with, version 8 of a particular library in development, and you don't want to necessarily switch everybody over to the new version 9 or whatever when it comes out, you can have an automated system that is building with this, running your test suite, and then it can just alert you that, hey, I've just tried out version 9 of this thing that you're using, and everything passes and say, okay, you're safe to move this into and deploy it out to your team, so that nobody will be broken and no developers will lose any time by trying out a new version. So it's doing that for you automatically. You have things like we can start to, and if we have an automated system, we can start to think about build revisions more like source control. We can fork them, revert them, merge them, branch them, all that kind of thing. We can integrate more tightly with CI from the very beginning. So if you're building your own libraries and your own packages for development, we can integrate that really, really tightly at the beginning with your CI. And then, like I said, there's no more sort of local hacks or Franken builds. Everything is audited and guaranteed from end to end. And that is one of the hugest benefits of having everything automated. So really, what we're trying to do with the ActiveState platform is to take all those disparate sources, to take our build engineering and expertise that we've had over 20 years in open source and systematize it and offer it as a service. So take all these disparate sources and processes, unify them, create a fully automated build pipeline that spans your entire SDLC. So we're providing sort of like a single point of interaction between various sources, processes, languages, tools to dramatically simplify your build workflow and automate away much of the pain here. So starting from developer machines and environment configuration, so getting your team up and running and not having to spend days installing tool kits and libraries and getting their build environments configured, being able to deploy that and have it configured instantly within, zero effort onboarding, all the way through getting you reproducible builds and providing you a repeatable system that you can integrate with things with like your CI, existing binary repos, all the way down to final deployment, getting that end-to-end automated and in a way that can be managed effectively in a reproducible, repeatable way is the goals of the ActiveState platform that we're dealing with. And so that's something that's in development, and we'll have more information about the platform later on in the webinar. But right now, I think I'd like to hand over to Sean to take a little bit of a deeper dive into some of the challenges, to give you some more concrete examples of the challenges that we run into kind of on a daily basis when we're doing a lot of build engineering for our language distributions.
Okay, thanks, Pete. So I'm going to talk today about incorporating open source into your build pipeline and how build engineering in ActiveState is helping you do that. It's hard stuff, but we want to explain why you still need to do it. Okay, Pete, next slide. So I'm Sean Lowry. I've been working for ActiveState for around 2 years in build engineering, and I'm now a team lead for the build engineering in ActiveState. We have a fairly large team doing build engineering, and we hope that we'll be able to leverage that for you. Okay, next slide. So there are a lot of pieces of third-party software out there, not just open source, that you can leverage to improve the quality of your products. There aren't many organizations that haven't already reaped the benefits of open source. And commercially licensed and closed source components like MKL and CUDA are also really useful things that you probably want to include in your build pipeline. Open source and third-party libraries give you a leg up, and they fill a gap in your expertise, and they can help you get to market quicker. So what I want to talk about is how to incorporate these components into your overall software build and why you'd want to do it from source. Next slide. So what's so hard about build engineering? Well, you've got a whole bunch of different components that you might want to pull in, and they're not going to come all from the same place. You've got to end up compiling and packaging a whole bunch of different things from different authors in different ecosystems. And when you're looking at open source components, not every author uses the same build tools. Not every author really cares about your platform. They have a set of operating systems and hardware that they particularly care about, and they may not care about what you're building on. And authors might be great subject matter experts, but not all of them are great engineers. I mean, we find this with some of the data science packages, in that the software isn't necessarily great, but it encapsulates dealing with the problems very well. Okay, next slide, please. So one of the things that we come across quite regularly is that authors have different preferences for compilers, especially when we look at when they're working across different platforms. So different compilers we find disallow different code. So you'll have some things that GCC, for example, will be picky about that, but MSVC won't care about, and vice versa. And the same is true for compiler versions. When you're looking at MSVC, at some levels it will quite happily compile code, but the dev kits and the compiler itself change from revision to revision, and you'll find that headers that you were including before aren't available anymore, and you have to do things somewhat differently depending on your compiler version. You probably need to do some portation of C code. So when you're finding C code that won't compile, you'll probably find that it's been compiled with a different compiler by the author, and that doesn't necessarily sit in your tool chain. So you're going to need to do some portation work to fix that. And back to GCC, GCC actually changed their ABI. So even if you actually get the code to compile, if you've got some code compiled with GCC4, it won't necessarily link and run neatly with code compiled with GCC5. Okay, next slide, please. Every author has their own favorite build tools, and generally they'll select a build tool that's available for the type of component that they're building. So quite often you'll find C libraries that will be built with auto tools, so the general auto configure make mechanism. Some more newer and more complex components might use Bazel, which is Google's new build system, which has an emphasis on producing reproducible builds. Newer C libraries and more so with C++ libraries, you'll see those built with a tool called CMake, which is actually somewhat better than the auto tools in some ways and somewhat more consistent. When we're talking about Python modules, those will usually be built with a script called setup.py that I'll come back to in a moment. Or you could have people who've got completely custom build systems. These things occur occasionally, and sometimes you just have to deal with them. Now, a setup.py, it's a particular problem for us because while there are conventions for creating a setup.py using things like distutils and setup tools, which are part of the Python distribution, those conventions aren't always adhered to. Sometimes you'll find that people can't quite cope with the restrictions the distutils or setup tools place on them, and they'll go outside the box. On Windows, this is really kind of Wild West as well, because we find people doing all sorts of things in the setup.py on Windows that have nothing to do with the traditional way of building a Python module. Okay, on to the next slide. So when you're managing dependencies, some of these you'll get a leg up from the ecosystem. So for example, Python packages will be managed by Python's ecosystem to a certain extent, although that's not always ideal. Sometimes when you're dealing with things like version pinning, the tools that come with the ecosystem might not act in the way that you want them to. And even worse, you've got C libraries. Those are just generally not managed as dependencies particularly well by any ecosystem. So when you're looking at Python modules, they will specify the other Python packages that they depend on, but there'll be no mention really of the C libraries they depend on underneath. Okay, next slide, please. So talking about C libraries, there seem to be three ways that people manage these dependencies. Sometimes they assume that they're already on the system, which is basically just kind of ignoring the dependency. Sometimes they will be included with the package source. So sometimes you'll find that something that depends on, for example, libxml will incorporate a copy of libxml in its source and build it as part of its build time. There are problems with that. If you include the source with a package, you'll find that it doesn't keep pace with security updates, and you have problems with version pinning. If you've got another module that's using the same C dependency and it's the different version, you may find that you end up with runtime incompatibilities. Some we've even found, especially on Windows, will actually download the source at runtime or a build time. So as you're building this particular Python module, it will go off to the internet, download a source package and start building it. For that, you're never really in control of it. It's unmanageable, and you end up with inconsistent builds, because if you end up with something that's downloaded at build time, you've got no guarantee that it's going to be the same every time that you end up downloading it. So on to the next slide, please. So I'm going to give you a quick example of something that a lot of people want because it's really useful, but it's actually quite hard to deal with in terms of build engineering. So TensorFlow is the go-to package for machine learning within Python, and a lot of people use it. It builds using Bazel because it is big and complicated. So sometimes you'll find that when you're trying to build a particular version of TensorFlow, it won't build with the latest version of Bazel. The TensorFlow builds tend to be loosely coupled, at least, to the Bazel version that they build with. So if you're contemplating building TensorFlow from source, you'll need to know which version you want to build and which version of Bazel you're going to need to build it. Which also means if you've got multiple versions, you're going to need to be able to manage multiple environments that have different Bazel versions installed. Also, TensorFlow builds tend to take hours. It's a large, complex project. It takes a long time to build. So you don't necessarily want that in as part of your continuous integration. If you're just sort of building on every commit, you don't want to be waiting for hours before your CI completes. So it's something you might want to consider taking out of your direct build pipeline. TensorFlow, everybody wants it to run fast because it does a lot of work. And there are a number of options for making it go faster. The instruction sets that you can optimize for include SSE, AVX, AVX2, and I believe there's now support for AVX 512. Not all of these instruction sets are available on every chip. So you can see benefits of up to 5 times performance improvement just through the instruction sets that you can use. So on a hardware that supports it, AVX2 is a really good idea. However, you will find that there will be environments that do not support all of the instruction sets that you want. There's also the option for GPU acceleration with TensorFlow. So you can use CUDA if you've got NVIDIA GPUs. So you may need compiled variants with the right optimizations for different environments. So you might have, for example, GPU support in production, but you may not have NVIDIA GPUs on everybody's desktop when they're doing development. So they'll need a different version of TensorFlow. So you need a way to both build these variants, manage them, and you need a way to be able to match and deploy the right variants to the right environments. So for example, you may want a project that runs from TensorFlow, and you, on your development machines, you end up using an unoptimized version or a version that just supports SSA3 and AVX. But when you go through to build, you might also want to have AVX2 and CUDA support. And when you get to actually deploy it, you may want everything turned on. You may also find that, with TensorFlow, one of the things that happened with it not so long ago was that Intel introduced the AVX 512 instruction sets, and TensorFlow binaries that were compiled to support AVX2 wouldn't run with the AVX12, or would come up with unpredictable crashes if you were running it on a hardware that had AVX12. So if you could compile and only have one binary for TensorFlow that has a specific set of optimizations turned on, when you come to run it in production, you may find that just changing the hardware underneath it, software that worked fine before doesn't work anymore. It's that sensitive to this kind of optimization. So you may find as well that, well, one of the things that we're aiming to do with the platform is be able to provide you with this kind of differentiation by allowing you to specify the components that you want in different environments. So throughout the software development lifecycle, you'll be able to specify a different kind of component, but compatible across all of your different environments, from dev right the way through to production. And incidentally as well, the other thing that allows you to do is specify that you want particular packages during development for tooling that you don't necessarily need on production. Okay, next slide, please. Okay, so we're going to ask about why you should go and do this stuff, because, yeah, it's hard, and the other option is just downloading free stuff. We're going to talk about why that's not a great idea and why you really should be building from source in your build pipeline. So there's three areas here. There's who do you trust, whether the binaries you've got are compatible, and whether the binaries you've got expose you to any liability. Okay, next slide, please. Okay, so the first thing we're going to talk about is trust. When you download something off the internet, you need to trust everything in the originating build chain. That goes right from the original software author to the build tools that they use to build it, to any external CI they use to generate the binaries, and the binary repo themselves. So you really want to know what's kind of where and how it was compiled, and you need to trust everybody in that pipeline. You need to know what else is in there. For some of this free stuff, it may come with adware, with malware, with spyware. There's nothing really guaranteeing that what you've got is built from the source that you've got, and that it only contains the things that were built from that source. You've got to work out how many people you are trusting in that chain. So each component might have multiple authors, might have multiple build engineers on the build chain, and multiple people maintaining the repositories. Can you trust all of them? And as you start to add more open source components, the more components you have that you draw in directly or through dependencies, the more people you end up trusting. One of the problems with that is, can you transfer that trust to your customers? Do your users and do your customers actually know that they are trusting all of these other people in the build chain? In some ways, you're forcing transitive trust on these users. Okay, next slide, please. So in terms of compatibility, are the build artifacts that you create actually compatible with all of the environments that they'll end up running on? So you'll have runtime dependencies. So for example, on Linux, you'll have glibc. On Windows, you might have UCRT or MSVCRT. With these things, it's generally better to have to build on an older platform than you're actually going to deploy on. Because when you're talking about glibc, if you build with an older one, your code is pretty much guaranteed to run with a newer one, but not vice versa. You also want to look at having a uniform compiler across your build chain. If you're downloading things off the internet, you've got no guarantees as to which compiler was used to actually generate the binaries that you've got. And you may find that there are incompatibilities, like we spoke about before, between the compiler revisions that we use to build these things. And as we were just discussing with TensorFlow, you may well have hardware dependencies that you actually need to manage. So you may need to deal with these instruction set optimizations and whether or not the hardware that you're running on has GPUs available. Okay, next slide, please. Okay, the last area really is liability. When you're talking about the software that you're pulling in, it may well have bugs in it. It may well have malware in it. What happens when one of these problems hits a customer? How quickly can you actually address it? If you're building with binaries, you're pretty much reliant on reporting the problem upstream and waiting for someone else to fix that problem for you, and then build it and release it. You may not want to wait that long. If you're building from source anyway, you can examine the source at least, and you've got a chance that you can actually get it fixed before you would normally get it in the life cycle of the component from the open source community. If you're building from source, you've got a couple of choices. You can patch your copy of the source from upstream commits. So basically, if the bug's already fixed but it's not been made available in a release or a binary, you can rebuild your binaries much more quickly if you're already building it from source and can patch directly from the upstream source. The other option, which is even quicker, is if you can find a fix yourself, you can patch your own copy and submit the patches upstream. And in that case, there's no need to wait at all for authors to address it in source or in binary form. So the other area of liability is licenses. Are your licenses that you ship, or your licenses and terms and conditions, I guess, if your users agree to a set of terms and conditions, are they compatible with the licenses for all the software that you have? If you're shipping software that contains third-party libraries, are your licenses compatible with everything that you ship? It's not just the stuff that you explicitly pull in either. There are packages that obviously will have dependencies, and if you're just dependent on the ecosystem, will automatically bring those in. Not all of them will have the same licenses. So you may find that there are libraries that have, or there are Python modules that have C library statically linked in with them, and they don't have compatible licenses. Okay, next slide, please. So one interesting example we came across recently was Wand, which is a Python module. It's a binding to ImageMagick. Wand itself has a pretty open license. ImageMagick has a different license to Wand. And depending on the version of ImageMagick you're using, it has different licenses. So for a long time, ImageMagick used to roll their own licenses and finally adopted one of the publicly available ones. And so you need to be aware of when that changeover occurred and which license you're actually distributing the software under. As Pete spoke about earlier as well, there are some kind of independent dependencies. There are dependencies that are kind of optional and aren't made explicit and aren't even really mentioned when you come to actually build this software and think about distributing it. Wand has features which bind to ImageMagick's mechanisms for manipulating PDF, for example. However, ImageMagick does that by using GoScript, which has a completely different license as well. So basically, you won't even find out about this necessarily until your customers come to use it. GoScript itself is AGPL, which is a particularly toxic license. Okay, on to the next slide, please. So what should we do about this? Building open source software from source can be really hard to deal with. There are a lot of different situations you might need to cope with, and you'll need to have consistency across your build chain in order to actually produce something that you know is going to work. The other option, not building from source, can be worse. It can open you to all sorts of liabilities. It can open you up to all sorts of runtime bugs and build time bugs that you would normally not have to deal with. And it opens you up to having to manage your own dependency chain to some extent. So really, we're recommending that you should incorporate open source software builds into your own pipeline. You should be building them from source. The other option is, of course, to outsource your open source builds to a single trusted source, such as ActiveState. We can provide you with sort of a trusted large section of that build pipeline. So you can trust us for everything from the source code onwards. Okay. That's it. So now I'd like to hand back over to Parker for some Q&A.
Thank you. Sean and Pete, that was a very interesting presentation. I'd like to just remind everybody that, everything will be available, after the webinar is completed. Give us 24 hours and it'll be on DevOps.com. And there are a few questions came in, and let's start with, how would you define build engineering? Pete, Sean?
Well,
did I ask a bad question?
no. It's complex.
Or there are 5 definitions. It's sort of like DevOps. You don't really know what the real definition is.
Yeah, well, that's exactly. And one of the terms that I used when I was talking was it's kind of like DevOps, but for development. But I think that build engineering involves all those things that I sort of mentioned earlier, which is around you know locating sources of libraries and tools and all that kind of stuff, compiling those things into artifacts, and then packaging those artifacts for distribution. So, but also focused primarily on that sort of early software development lifecycle stage of getting things going. So it's I guess if we're trying to boil it down, something like getting all those sources of libraries, languages, tools, compiling them into artifacts, packaging those for distribution is sort of what build engineering encompasses.
Yeah, and it might depend on the application it's in too, what you're build
Yes.
engineering for. But that's, I learned that with DevOps. It can, definitions can vary. Are you talking about culture? Are you talking about tools? What things are you talking about? And that's what my experience is. So, well, with that, but
Yes.
I think that's the best answer you can give, as I've tried to answer the DevOps question many times, and I still don't have the right answer. I have another one for you. Why isn't talking about the missing link between build engineering and SDLC?
I would say probably it's not getting talked a lot because I think it's generally taken for granted that it's just something that everybody kind of has to do, the kind of, to use that popular term, yak shaving that people have to do just to get work done. But it's actually a pretty critical part of the whole development process, and is really, really important to being able to do development at all, but also to have, as Sean pointed out, like consistent deployment things that will work on all the platforms that you're pushing to. Sean, I don't know if there's anything you want to add, or.
Yeah, no, I think you've covered it there. I think there are just kind of those hidden costs involved with that missing link, that people have kind of glossed over as just part of what they have to do. And it's we're now trying to quantify that a little bit.
I think that's a good point. It's always a few too times is cost taken into account when people get into a project and they realize, oh, now I have to think about cost and this isn't working as I planned. That's a very good consideration to add. I have another one for you. What are the OSS builds you provide?
So we provide, at the moment, we provide Active Perl, Active Tickle, Active Python, and Active Go, which are all kind of curated distributions of the various languages and the most useful and most used packages that we find for them.
Mm-hmm.
And those are provided generally also on. We have community editions of those that are free to download, and those are available on Linux, Mac, and Windows. But then we have also enterprise editions for large enterprises that support Big Iron as well. So things like Solaris and HPUX and stuff like that. So there's also kind of esoteric platform editions of all those languages and OSS distributions.
Oh, I got one that just came in. I think is sort of, it's sort of one of those that's interesting and philosophical. What is the difference between DevOps engineering and build engineering?
Good question. I think DevOps engineering kind of covers a whole bunch of stuff outside of just general build engineering. It encompasses all of the infrastructure and continuous integration tools that kind of sit around where build engineering, the core of build engineering, really lives. So it's those things that basically help get from source to deployed bits. But inside, there's all of this stuff that we're dealing with here in terms of actually, how do we get those components? How do we take, how do we take a piece of source code on a machine and turn it into bits that we can use?
Would you consider, as I'm listening to that, would you consider build engineering more, let's say, finite, and DevOps engineering more broad?
Yeah, I think it's kind of it's slotted in there. I think the DevOps engineering, they have to deal with a lot more in terms of the local environment than necessarily build engineering will, and just in terms of company culture and how they actually go about deploying or selling software.
Oh yeah, because DevOps, a lot of discussions about culture. I'm sorry, did I hear you add something?
I was just going to say, I think that's a really good point about that, and in terms of like local environments and stuff, but also the focus on deployment also is around a lot more considerations around scaling with DevOps, whereas with build engineering, it's sort of, as I mentioned, it's a lot more focused on the development side, right? So it's
that's what I see.
It's not as concerned about that. Yeah.
And it's important to differentiate those two so people understand, the purpose of each and the value of each term. But again, let's remind everybody, it's just terms. You still need the tools to get anything done. And here's another question. This one's a little longer. What is the better, I like that, the better best practices? I personally say bestest best practice. One team creates a standard big build for all our projects, or should each team be responsible for creating their own specific builds? Does that make sense, or should I read it again?
No, it does.
Yeah. I love the word, the better best practice. There should be a word bestest,
It's just, I think that it probably is dependent on whether you have the right processes and tools in place to make something like builds per team feasible. So generally speaking, I think that if you had an ad hoc build engineering practice, then you probably don't have the bandwidth or the systems in place to effectively do per team builds, and that you're probably better off with a kind of monolithic build across teams. However, if you have a robust automated build engineering practice, like with the ActiveState platform, it opens the door to you being able to have customized builds per team, where you can have a customized environment that for your team that's easily deployed and easily shared amongst everyone in your organization, so that it's not hard for somebody on another team to get your environment running. That's one of the benefits of having the monolithic one, is that if you have our common development environment or whatever running, then that it's going to work across everybody, because usually getting an environment running is super complicated and like really time consuming. Whereas if it was in a situation where it was trivial to get something running, then maybe it's, then you can, have the benefits of having your per team customized build environment instead of having this really bloated monolithic one. You can have something that's specialized to your team. So I guess it's a long way of saying it depends.
Yeah, I think it also depends a lot on
sometimes not.
I think it depends on how tightly integrated the outputs of the various teams are, and if they have dependencies on one another. So I think there's benefit where you've got things like, say, for example, you're deploying a Go microservice in a Docker container. It might make sense for that to be done on a per team basis. But if you're building a library that a lot of other people use, it's probably better to actually integrate that into one big integrated pipeline.
Well, and that makes sense. And it's like everything else in development. There is no exact science. There's not, you have to look at every situation. Not one thing works every time. Like you said, depending on their current situation, where people are going, what they want to accomplish, what tools they have available. But with that said, I mean, we're about out of time for questions. But a couple of questions have come my way in a private chat that how do we get in touch with Pete and Sean? If we
Right.
want to talk to them further, because this is very interesting and it's very important. And obviously, how do we get in touch with Active also? But specifically, you two, can you talk a little bit about how to reach you?
Right. So we've put up the slide that has information about if you need to get information on the ActiveState platform, you can drop marketing and ActiveState a line, and you can watch a demo here. And there's additional information at platform@activestate.com. I think that if you say you want to talk to us specifically at one of those emails, it will find its way to us. So you could say that. But you can also, I mean, for me, you can find me on Twitter at Rocktron, RAWKTRON. So if you find me on Twitter, you can, I'm usually pretty responsive as well.
Oh, that sounds great. One last question came in. What are the tools or best practices to improve build stability? Building new releases that behave the same as old releases. I want to get that one in, but that sounded really interesting. The behavioral question of new versus old.
Yeah, I mean that's an interesting question. Maintaining compatibility between versions of between releases. Again, the best tools I think really are going to be unit tests and functional tests integrated into your pipeline. This kind of thing is probably best dealt with by unit tests and a decent set of regression tests. Because really, when you've got source code, especially when you're pulling in open source code, what you really want it to do is make sure that it actually works for your use cases. So what you really need is a decent test suite, I'd say.
Well, some of these last minute ones, we got some more. I'll try to get to as many as I can. And how do you allot for standardizing builds across teams when there may be different package requests based on applications you're developing? These are good questions. You got to think about them, Want me to read it again?
Yeah.
just like Family Feud. And how do you allot for standardizing builds across teams when there may be different package requests based on applications you're developing?
Yeah, I don't think that's necessarily a big issue. Certainly with the ActiveState platform, you'll be able to define very clearly the runtime on a per application basis. So you'll be able to build multiple runtimes or runtimes that will run multiple applications just by picking and choosing the packages that you need. So that's one way that we're helping to deal with it. Yes, it's a problem, and it's a problem we're trying to address.
Okay. Well, with that, I want to thank you two, Pete and Sean. You've been great. Let everybody know again, we're at ActiveState.com, and I think if you look at your screen, you can see how to get in touch with everybody. And as you know, in 24 hours, this webinar will be available on DevOps.com, or you can reach out to ActiveState and get a copy from them directly. I'd like to thank Pete and Sean and everyone for attending, and really have a great rest of your day. Take care. Bye from DevOps.com.